This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Are you a tech-savvy developer with an inquisitive mind? SE Radio has an opening for a new volunteer host to join the team and produce 5 episodes per year. Contact show editor Robert Blumen at robert.blumen@gmail.com for details.
Hello, my name is Adam Conrad for Software Engineering Radio. Today we have Chris McCord talking about LiveView in Phoenix. Chris McCord is an architect at Dockyard, the creator of Elixir's web framework, Phoenix, and author of Programming Phoenix 1.4 and Metaprogramming Elixir for the Pragmatic Bookshelf. Chris holds a bachelor's degree in computer science and has extensive web development background. You can find him traveling the globe, speaking at conferences, giving workshops, and advocating for Elixir's budding community. Chris, thanks for coming on today.
Thanks for having me. Excited to be here.
So I want to get started by talking about the whole ecosystem of Elixir and Phoenix. You've contributed primarily to the Phoenix framework, which we've talked about previously in episode 349. I'd also like to take a step back and talk about Elixir as well and go through the whole stack. So we did have a previous discussion on Elixir on episode 336, but if you could just give us a brief overview of Elixir and Phoenix.
Sure. So Elixir is a relatively, I'd say, newish programming language. So it was started in 2011. I believe it went 1.0 in 2014, but I say young, but it's actually quite stable at this point. It's been 1.0, been used in production for at least 5 years now by many companies. But Elixir itself runs on the Erlang virtual machine. So a lot of times we can't talk about Elixir without talking about Erlang. And you can think of like Elixir kind of like how Clojure runs on the JVM. Elixir runs on the Erlang VM. So much like we're used to these JVM-based languages, we kind of get to bootstrap the language with everything that's available. So Elixir didn't have to reinvent the wheel and kind of build a standard library, build web server, build a bunch of libraries. It was able to come in and take advantage of the Erlang VM. So Elixir specifically and Erlang give us kind of a unique paradigm for development. So it's not only a functional language, but it has a concurrency model that has preemptive scheduling. So it allows us to scale to millions of users per server and really build distributed systems in a much different way compared to most modern languages. So I'd be happy to get into the details there, but kind of the big goal with Elixir was building on the Erlang heritage, some modern features with polymorphism, with modern build tools, a package manager, and kind of like all of the modern features of a language we'd expect today, but building on kind of all this innovation that Erlang has proven out for the last 30 years. So that's Elixir, and Phoenix is kind of like the de facto web framework for Elixir. So I started Phoenix well before Elixir was 1.0, and I believe Phoenix went 1.0 in 2015, but it's been 4 years now. I'd have to go back and look, but Phoenix itself, similar to Elixir, at this point is kind of tried and true, has many success cases out there powering companies like Bleacher Report, companies at a high scale with hundreds of millions of visitors. So at this point, we've kind of, proven to the world that we're able to be successful and give people kind of unique advantages. And I'd still consider us kind of in this emergent market share, but we're hoping to, continue to advocate and grow where we can.
And so you had actually worked in the Rails space before, is that correct?
That's correct. So if you're at all familiar with Phoenix and Rails from Ruby, you will probably see a lot of similarities there. So the creator of Elixir, Jose Vilim, was on the Rails core team, and professionally I had worked building primarily Rails applications for 6 years prior to starting Phoenix. So I think that you can see we borrowed a lot of good ideas, and I think we also learned a lot so we borrowed a lot of the good things from Rails, and we also try to take the lessons that we learned from maybe the not so great experiences that we had and applied that to the framework.
Okay, and so then how did you know that there was an opportunity for a web framework? Were you looking at Elixir and saying, okay, this might be a good opportunity for a language that needs a web framework, or were you looking to create a web framework and then Elixir happened to be the language that worked for that?
Yeah, so I had no, I don't, standing where I am today, it's very bizarre because I had no plans to kind of be where I'm at. But so initially, I was trying to do a lot of real-time events with Ruby and Rails. So, I was working at a consultancy, and more of our client requirements were coming down to do kind of real-time events in web applications. And I loved Ruby at the time, and so I was trying to see how I could make the real-time web work with Ruby and Rails. It's kind of where all this started, and I quickly found out that was not going to be a viable path. So I had worked on a library to do kind of real-time updates with Rails, and I knew it wasn't going to scale and it wasn't going to be reliable. So at that point in time, I started looking around to say if I want to build the kinds of real-time applications that I know I need to build, what's the best option, and especially what's the best option that kind of gives me the feeling of this quote-unquote mystical productivity and enjoyment of coding that I had known from Ruby. So that's kind of where it started. So I was looking around, I tried Go initially over a winter break, and that just didn't feel right to me. It was more of a feeling thing. I think Go, you could write web applications that scale and that are real time with Go. But I tried Go for a couple weeks. I looked at Rust, and ultimately I found an article on Erlang in the context of WhatsApp. They had just been acquired for $20 billion. And I had seen that they had been running 10 million or millions of users per server. I forget the number at this point. And that kind of piqued my interest. How are they running, millions of connections on a single server? And I found out that they were using this language called Erlang. And that's when I had remembered that Jose Valim from the Rails core team had retired from the Rails core team to go start a language. And that's where kind of it piqued my memory. When he went off in 2011 to start his own language, I didn't really follow that development, just thinking what's this crazy idea that he's doing. But Erlang reminded me that Jose had gone and created this language called Elixir to run on the Erlang VM. So that's kind of when I got excited by the prospect of scalability with Erlang, and I remembered Elixir was this little thing that was started. So I think it was just kind of the right timing there to pick up Elixir when it was very young, and I got hooked on Elixir immediately. I fell in love with the language, so all I needed to do in order to use it for everything I wanted to build was write a web framework. So it's kind of how that happened. It was more like a hobby, labor of love. I found this language, and to build real-time web apps, I needed to build a framework because none existed in Elixir at the time. So that was kind of the start, just kind of a humble hobby project, and people started using it, and here we are today.
And as part of that work in trying to create real-time applications, LiveView is now a big part of that experience. So I want to shift gears over to LiveView, since that's one of the bigger features you're starting to launch with Phoenix. So could you just give us a quick overview of what LiveView is and what inspired you to create it?
Yeah, so LiveView is a way to build kind of rich, interactive applications without having to write JavaScript. Because one of my pain points working at my previous consultancy was just every single page app that we ended up writing ended up being, taking 10 times as long and being 10 times as hard to write for seemingly little gain. A lot of times we just had some kind of interactive features we wanted to write, and the only way to accomplish that was to write a bunch of JavaScript and adopt a JavaScript framework. So that's what I was trying to kind of accomplish with my real-time Rails features, was how can I have real-time features without writing JavaScript. So the inspiration was there from the beginning when I was looking around other languages, but LiveView only recently happened, so it's been in development for about a year. But it took us, we had to build all the plumbing with Phoenix web layer, Phoenix's real-time layer, Phoenix pub sub. So we had all these building blocks that allowed us to kind of last year go back and accomplish the original vision of the kind of thing I was trying to solve with Ruby, which is being able to write real-time applications server rendered, but giving you almost all of the benefits that you would come to expect from a single page app. So that's really what LiveView is about, is being able to write applications that are server rendered, but give you much fewer trade-offs and much more benefits than I think that you would imagine. I think when people kind of originally hear this idea, they think it's crazy, they think it won't scale well, they think it's going to perform poorly, they think it's going to be a bad UX, and I think we can actually show that we can beat single-page apps for a lot of use cases compared to something that you write by hand in, let's say, React or Ember.
So what inspired LiveView to be created? And how is it evolved from lightweight systems like PJAX or TurboLinks? So for example, with Rails, we had TurboLinks as a lightweight solution for interactivity on the client side. Is this the equivalent for Phoenix? And how has it evolved since that model?
The inspiration came from, what I was trying to accomplish in Ruby and Rails originally was, how do I render or how do I perform real-time updates without having to adopt a single page app and all that complexity. So it's rooted in what I was trying to solve with Ruby, 7 years ago, but we weren't able to try to accomplish that until about a year ago in Phoenix, because we had to build the web framework and the real-time layer and the pub sub layer. We had to do all the building blocks first, and that's what enabled us to get to the state where we could start trying to accomplish this. So the motivation was, how can we get the real-time features that we have come to expect from modern web applications without the complexity of a single-page app? Because there's a lot of complexity there to get kind of the UX that you're going for. So how it's different though from Turbolinks and PJAX is, I think it's a comparison that we see folks make a lot, kind of looking on the outside. So I think there are some overlap, but it's very minimal. So the overlap is Turbolinks and PJAX allow you to update the page without a full refresh, and that's kind of where the comparison starts and stops. So in that light, they are the same as far as not doing a full page refresh, but Turbolinks really is a stateless approach, and that's the big difference with LiveView, because LiveView is stateful. So with Turbolinks, you're doing an HTTP request, and you're with Ajax, and then you're either not rendering the layout, or you have the JavaScript just strip the layout, and you just do like a body inner HTML replace. So it's kind of a very simple model that gives you maybe a snappier feel web page, but it's still a stateless request response. Where LiveView is actually kind of like the React programming model that we put on the server. So we're running a stateful process. We call Elixir very light threads processes, but we're running a stateful program per browser tab running on the server for every user. And that allows us to do things that like Turbolinks model just can't do. So one of the best examples is if you're trying to build, let's say, some event queue or some real-time system on the back end that, like, as an event happens, you want to update the user's web page. Well, with Turbolinks, the only real way to accomplish that would be to have like the Ajax just pull the server over and over and re-render. But with LiveView, we have a running program running on the server, and as those events happen, we just update our templates and the UI is going to update for the user. So I think this bidirectional stateful difference is the key that kind of unlocks the potential for LiveView. So it's going to allow us to kind of do all these neat optimizations that we can go into, and it's what allows us to be much faster latency wise, because we're running this over a WebSocket connection, so we don't have all this HTTP overhead. We don't have to hit the databases often. So I think it's a very different approach compared to PJAX and Turbolinks, even though on the surface there may be some comparison if you're looking at just kind of the not having to reload the page kind of mindset.
So in understanding the model here for LiveView, what I'm starting to understand is that fundamentally something seems wrong with JavaScript in JavaScript development for client to server interactions. What do you think is wrong with JavaScript?
Yeah, so I want to carefully answer this because I do think JavaScript allows us to do a lot of things that are impossible to do otherwise. So, I don't want to put down an entire ecosystem, but I do think that a lot of us have experienced this pain of modern JavaScript development. So I think what I've personally felt, so I'm going to come at this from like this personal pain perspective. So I've worked at consultancies for my entire professional career, and so I've had insights to, many dozens of different application domains, business models, and every time we've gone all in on a single page app from my experience, it has always been way more complex than its kind of server rendered counterpart, way buggier, way harder to actually keep up with the pace of change, because of the JavaScript community, by the time you ship your product, may have just changed the framework that is now kind of the de facto way to go, or even the framework that you chose may have had breaking changes. So it's, I think, a combination of things. But this is all to say that folks adopt single page applications, I think, for good reasons. Like, we have valid business reasons to say we need to have a rich experience here. So one of the obvious ones I'd like to give is like a registration form, right? Like, we want to have client-side validations because we're trying to increase conversions to users signing up or buying a product. Like, we have good reasons for taking on this pain. But for me, I feel like a lot of us take on this complexity and pain because we have to accommodate these few features, right? Like, we need this interactivity here, we need this client-side validation here, we need to have a chat box here. But the rest of our app could just be server rendered otherwise. So I think a lot of us buy into the complexity for good reasons, but it's a huge burden where if we had an alternative that existed that gave us, these rich bits of rich UX that we could otherwise, operate with a normal server rendered model. That's kind of the dream that we sell with LiveView, and in practice, we're seeing that pan out. So I think that the pain comes from just overly complex solutions, trying to write stateful applications on the client, then put you into a distributed state problem. So I think just the model itself, single-page apps, is just inherently more complex, and that's kind of what leads to the pain.
And based on what you're saying, it sounds like it's an additive solution, not a replacement. So in other words, you can use JavaScript in some places and LiveView in others, or even on the same page?
Yeah, you can. So we give you an escape hatch to write JavaScript as needed. So, the goal for us is to do as much for you as we can, but there is a happy medium. Like if you're trying to do charting, you can use a charting library and feed it data from the LiveView and still render the rest of the page with, server rendered HTML. So those two worlds do coexist.
And then understanding a bit more how LiveView works, is LiveView JavaScript or Elixir or a combination of both?
So it's a combination of both. So I think at the moment it's like 1,300 lines of JavaScript that we write for you that powers all of this. So it's actually not a lot of JavaScript, and one of our explicit goals is to not create a JavaScript framework in our effort to not have folks use a JavaScript framework, right? So if it's a 300 kilobyte payload to load LiveView, then we will have lost, right? That doesn't make sense. So our goal is to so really the real innovation happens on the server with LiveView, but ultimately it does require JavaScript on the client to update the page. But I just want to make it clear though that what we do send on the initial page render is just HTML. So even if you're a web crawler or you have JavaScript disabled, you will get a rendered HTML page. So there isn't any of this like skeleton page that we hydrate later. It's just an HTML render. So there's a lot of benefit that we get even if we have JavaScript running behind the scenes once we connect to the server.
Right. So even immediately, one of the benefits with LiveView is for SEO purposes. Since you have a full HTML page, you can now immediately distribute that, whereas opposed to a SPA, you might have some challenges with being able to fully showcase all of the content that's available.
Yeah, exactly. And I think the other thing I want to highlight with kind of going along the lines of what's wrong with JavaScript, I want to also highlight just in general, I mentioned the complexity in the model of just a single page app. Like it's inherently more complex because now you have client-server interaction, you have to define all those contracts, what those payloads look like, how to render that on the client. And what LiveView allows us to do is not only skip all the single page app JavaScript complexity, but it also removes an entire abstraction layer of just web development, which I think is actually really important. I didn't actually fully appreciate this until after LiveView was written, and I went back and tried to use it as a user to appreciate like just how much actually falls away. So if you imagine, even from the simplest feature that you could write for a client-side app, you're going to have some level of server communication, right? So you have to create some kind of HTTP endpoint, whether it's a JSON API, whether it's GraphQL. You have to immediately start writing this kind of glue code between the client and server. So it's going to involve setting up the route in your router. It's going to involve figuring out the naming for the controller. So now you're making naming decisions, and these are all easy to do, but you're making all kinds of decisions just to get kind of these client-server worlds glued together, and then you're having to write kind of what the payload looks like on the server. How do you serialize the data structures in Elixir or whatever language you're using, and then you get them back to the client. The client has to also be aware of this kind of payload contract. So there's all these like decisions and touch points just to get a message to the server and back to the client, where with LiveView that actually completely falls away. So I mentioned it's kind of like React on the server. So there are no routes once you're connected. You're just interacting. You annotate your DOM, and those send events that get called on your Elixir code, and all of that happens for you. So this entire router, controller, payload contract layer just completely disappears, and that vastly simplifies the programming model of building a web app. It feels like cheating, is what I like to say, and it's kind of even for me as a creator, it feels like it shouldn't be possible once you kind of get in this mode of writing applications this way.
And you had mentioned that it really didn't surface for you until you actually started writing an application. What was the first application you used to test this out?
Yeah, so the very first one was this quote-unquote client-side validation use case. Just because that's what so often I've been hit with personally when building out apps. So it's just like, you have server render HTML and everything works as it should. Everybody's happy except for this registration process that you want, as a user's typing, you want to tell them that they can't, put a hyphen in their username or that their email's already taken. And that's where like you immediately now spin all these cycles on like setting up Webpack. Do you bring React in? Do you pick a framework? And assuming you can do that, like how do you get like localization down to the client? So you start adopting really a mountain of complexity just to get like one of your pages kind of somewhat interactive. So that was the very first approach for me, was like a non-optimized live view where I took my Elixir code that I'm used to writing for a server rendered no JavaScript registration page, and I said, what if I could just take that same HTML I'm used to writing that shows you your validation errors, but you have to click save first? What if I could just re-render that on the server, let's say on every key press? And that was kind of the model I took initially and kind of prototyped out this idea. And so yeah, that's where it all started. And now, that was a very naive approach. We were rendering all the HTML. We were sending the HTML over the wire on every keystroke. It was very expensive, but since then we've been able to introduce optimizations that actually makes it, in a lot of cases, better than the best handwritten JSON that you could try to spin up in a single page app, even though it seems like that would be impossible.
And so for our listeners, are there any sort of sample applications or ideas that they could use if they wanted to try out just a starter version of LiveView just to get going with something?
There's a phoenixfrenzy.com, frenzy with a PH. Dockyard just hosted this competition for the community. I think we had like 30 some, close to 40 entries of people just building whatever they wanted and competing for the best application. So that's kind of like a showcase of examples. People built a lot of games, which is kind of, surprising. Like, gaming was not an original target for us, but like, people have built chess, they've built Tetris, they've built like actually compelling games out of this server rendered approach. So that's a good place to check out. And underneath my GitHub, there's a Phoenix LiveView example repo that has maybe half a dozen applications where, we show the real-time validation. There's a thermostat with like the current weather. We show pagination, infinite scrolling. So kind of just like some basic things that you would try to do in an app, right? Like we support push state as well. So there's an example in there of pagination with push state. So you're able to do next page without actually having to experience a full page reload. So that's kind of where maybe the TurboLinks idea comes from, but I think we have a good example between Phoenix Frenzy and then the LiveView example repo that at least get people started.
In general, it sounds like writing a component in LiveView feels like writing a component in React or Vue. So would you say that if you're considering using React or Vue or some other major SPA framework, that LiveView could be an interesting substitute?
Yes, absolutely. So yeah, LiveView supports the same kind of component idea, so you can write reusable components. And I think any interactive application that you may consider for, let's say, React or Vue, I think LiveView is at least worth a look. We like to say that there is a limit at which I think it makes sense to write a single page app. So I think our goal isn't to say that we obviate all single page applications and frameworks, but I do think that we remove a large class of them from requiring a single page app framework. So I think, if you're trying to build Google Docs, absolutely you need to write client code. If you're building kind of ambitious desktop-like experiences, by all means, pick up one of these great frameworks. But I think there's a large class of applications that probably the majority of us are building that kind of fit in the middle, where you need some, bits of interactivity. And I don't know where the limit is yet, so it's kind of a case-by-case basis, but the limit keeps going further out. So I think a year ago I said, I didn't know if you could build a chat application with LiveView and have that be like an effective experience. But at this point, people are building chat apps, and they're doing it effectively with low server utilization. The data payloads on the wire for the chat app probably often be a equivalent React chat app that you would try to build. So it's hard to say where the line exists, but I do think it's at least worth a look if you're building kind of any kind of interactive application.
Maybe to help the listeners figure out the differences, if we could dive into the render cycle, maybe see how the differences are between LiveView and a traditional SPA.
Sure, yeah. So I think the render cycle is what is our like secret sauce, and I can credit Jose Valim, the creator of Elixir, has worked on really almost all of the optimizations that make LiveView amazing. So I owe him a huge credit. But what we're able to do is we're able to take you write a LiveView template like you're used to writing any other server rendered HTML template. And the way that we make that performant for all these updates, because if you imagine you as a user is typing a character or clicking a button, every change they make, we have to re-render it out on the server, and that's the programming model, just like React, right? Any change you make to your state, React re-renders your template, and it does a VDOM, a virtual DOM diff, to make it efficient. But on the server, the way we make this fast and efficient is we have the same approach where you change your state, we re-render your template, but our templates internally do change tracking. So we'll actually only execute the Elixir code that has changed. So it seems like it's expensive on the server, but we actually only at runtime execute the code that's necessary to be executed. And then the data on the wire, we almost do like a virtual DOM on the server. So the data on the wire that we send isn't your whole template, even though the programming model seemingly is we re-render the whole template. We actually only send a diff of the content of the template that changed on any given change. And all that content is only, it doesn't contain any of the static HTML. So I mentioned it's kind of like virtual DOM, except it's way more efficient than virtual DOM on the server because we're not DOM aware. So if you have a bunch of HTML on your template and then you have like a dynamic class on it, the only thing that we would send down as the diff is the string that changed for that class name, not all the div and table rows. And then what we do on the client, similar to React, is React has a virtual DOM on the client, which allows it to do an efficient DOM patch. We use a library called Morph DOM, which allows us to. It's very similar to virtual DOM, except it uses just pure DOM interfaces. But we take on the client, we patch the DOM by taking the diff from the server. We recompute what the template should look like on the client, and then we take the current DOM on the client and we say, here's what the DOM should look like now, and then Morph DOM figures out how to apply that in the most efficient way possible. So one example is if you just change the inner text of like an H1 tag and you gave it a whole template, it would compare the whole DOM structures and ultimately just execute like inner text equals new value. So Morph DOM allows us to do an efficient DOM patch just like React. So at least hopefully that gives some insight in the model.
This actually sounds similar to dirty checking with something like Angular, because you're actually comparing both sides to say, well, what is the diff and how do I fill in the information once it's changed? And so is the server then serving as the dirty check reference, if that makes sense?
Yes, exactly. So it's been many years since I was involved in Angular in the Angular 1 days, but yes, that actually sounds like a good analogy. And this is kind of what I touched on earlier with how TurboLinks is the stateless for stateful model. This is why it's very different. Because we have this state on the server, we actually know what changed, right? It's not like the client. You could mirror or you could try to recreate a LiveView-like approach, and we see other communities doing this over stateless HTTP. But that would involve the client sending up its state on every interaction. So the client could pass, let's say, all the quote-unquote state on every interaction, and then you would have that in your callbacks on the Elixir side. But that would not give you the stateful dirty tracking or the optimizations that we're able to do. So since we know what changed because we have this process up and running for the entire life cycle. So that's kind of what enables all of this.
And what's interesting now that you're saying this, and you've mentioned this multiple times, that this is a stateful model, whereas the other forms are stateless. The interesting thing here is that Elixir is certainly touted as a functional language, and anytime you talk about state to a functional programmer, they're going to wonder, is this the right way of doing things? So how do you handle state in a way that still maintains a functional paradigm?
Yeah, so fortunately for us, Elixir and Erlang were built on these primitives, so we handle it exactly the way it's supposed to be handled. I know that sounds weird, but there is only one way to build stateful applications in Elixir and Erlang. So it's not a unusual approach. Like the way we do it is with primitives built into Erlang's standard library. So this is all to say that it's still a mutable state and it's still a functional paradigm, but all these primitives were figured out 30 years ago. Erlang's was built in the 80s. So they took this kind of immutable functional language with this unique concurrency model. And over the course of X amount of years, they figured out they were writing stateful applications in the same way. So they wrapped that up into a library that we now refer to as OTP. And Phoenix and Elixir and with LiveView, we take advantage of all that. So the way that we're actually doing this on the Elixir side is very natural and not unusual at all. It is the way you write a stateful application in Elixir. It just happens to be connected to a browser tab on the other side, but it's very natural and has been shown to be robust and scale out to millions of users.
And so does that also mean that you don't need Redux? If you're worrying about state management and the Elixir server can handle the state management, it almost sounds like not only do you not need React or Vue, you can also swap out Redux as well, since the server is now the central store for state.
Yes, exactly. And I think that's what's interesting to me too about Elixir is I think a lot of the problems that are being solved on the client side with JavaScript and a lot of the pain we experience with library churn is because these primitives that we have, let's say on the Elixir side and in other languages, don't exist in JavaScript. So you see the communities kind of come up with libraries like Redux, which allows you to, my understanding at least, I'm not a user of it, allows you to like serialize events and data flow through the system, if I'm not mistaken. These primitives just exist in Elixir, right? So the way that we build stateful applications in Elixir naturally lends itself to our units of concurrency receive messages in serial. So I think a lot of these solutions that we see in other languages just exist as part of the platform, which kind of removes all these layers of trying to choose a library and learn a library. It just naturally kind of falls into the programming model that we're used to writing on the Elixir side.
So is there an ideal application that LiveView is suited for?
So what I like to say is it's especially well suited, I think, for kind of the boring business problems that we're all solving over and over, which is a large class of applications. So that's not a very specific answer. I'd say it's from two sides. If you're writing a static HTML template application today, let's say that your requirements are just render some tabular data, let's say. Now you have the option just to make that real time out of the box with the same amount of work. So I think it unlocks potential for applications that you're already used to writing, and it also allows you to accomplish those more complex user experiences in much less time. So any example of trying to do any kind of real-time updates on a page, dashboards are a great example. Anytime you're trying to display information that's frequently changing and you want the client to update, now you can just write a single line in your LiveView that subscribes to some pub/sub events, and then two more lines of code, and now your dashboard is just updating with the current request per second, the current weather, the current tickets, whatever you need for your business. So I think dashboards are a great example. Any bits of rich interactivity like sign-up forms. Checkout is a great example, like building a commerce solution in this. Anytime I check into my flight, I always think this would be a great LiveView experience because you always expect the server has to be there when you select your seats. So I think a large class of standard business applications would work. The only thing that it's not good for would be something that requires like offline mode, because clearly since we're server powered, if you can't connect to the server, then that leaves you in kind of a read-only state. But I think that we haven't found out where it's not a good fit yet, provided that you don't need offline support or kind of like desktop-like functionality.
So there's no opportunity to keep retrying or have it talk to a local storage mechanism in the interim, or is that something for a future iteration?
Yeah, so to be clear, we keep retrying. So it's actually funny because I found out just like a week ago that Google Docs doesn't work offline. I just assumed it did. Like I use Google Docs as an example when I talk about LiveView as like, I still don't think you would write Google Docs in LiveView, to be clear. But I always use that as an example of here's clearly a bad fit, but I actually turned my Wi-Fi off and my Google Doc, which I assumed would be interactive, it went into read-only mode until I reconnected. So this is all to say that it's like a very gray area. But what LiveView will do is it will turn the page into like we'll do like a CSS cursor where it will change the pointer to an inaccessible cursor, and it will set a Phoenix disconnected class on the LiveView container. So by default, out of the box, you get connection recovery, and you get the page updates with like a loading spinner, and with a CSS class that you can override. So to be clear, your app gracefully quote unquote degrades when it disconnects, but it becomes in like read-only mode, right? You can't interact with it. So I do think there are some possibilities to make that. There are some possibilities for us to do some local storage ideas, but ultimately, if we're very limited because if there's any logic around the user interaction, that logic lives in Elixir, and we can't apply that yet to the client. So I'd say if you do need any rich interaction offline, then it's an obvious case to use a client-side app, and I think that's not a problem. It's what the client-side solutions are good for. It's like if you have to run code on the client, then you've got great options available.
And that makes sense too, because really in this time in this year, we're more worried about low or bad connections rather than absolutely no connection at all. And so you're saying that by having the ability to do these optimistic retries, if you do have a bad connection or low service, it still allows it to have somewhat of a seamless operation.
Yeah, and we have, optimistic UI is another one where if you want true optimistic UI, we won't be a good fit, but we do have some optimistic UI features, and we do hope to grow them as well. So, for example, you can, when you submit a form, you can annotate the DOM to say swap out the form text with new text like saving ... or whatever you want it to say. So we do have some optimistic UI features already in place, and I do think we can kind of push the bounds there. But if you're trying to physically render, let's quote unquote render a template on the client when you're offline in an optimistic way, that's just not going to work. But along this point, I think a lot of folks initially hear this offline mode and then think, oh, well, LiveView's out then. But in my experience, the vast majority of single page apps also don't work offline and perform poorly when there's bad latency. So it's actually a big complexity buy-in, even if you're all in on a single page app, to fully go and support offline mode. So I think most single page apps degrade very poorly because they often expect the server to be snappy, so that a lot of times they won't even do optimistic UI, and you just click save and nothing happens, and it's a worse experience than just like waiting for a regular forum post because you don't even get any browser indication. And there's also this issue of once you support offline mode, you have to handle data synchronization on the client and server. So anyway, I think a lot of folks like to troll me, especially with like, what about offline mode? So they either troll me or they legitimately think, well, since it doesn't do offline mode, it's not going to be a good fit for me. But like I said, by and large, that's a complexity that you have to adopt on a case-by-case basis because it's not free to support offline mode, even if you have a single-page app.
Right, and even then, being exhaustive about what the feature sets are doesn't negate the fact that in the real world, how often are people really creating pure offline applications that have to talk to a client-server model? Like I said earlier, it could be more about low connection or bad connection rather than no connection at all. But in my mind, I also think one of the upsides here is that you're showcasing that LiveView isn't perfect for everything, and one of those cases is offline. Are there other examples or downsides to getting started with LiveView?
Yeah, so offline is the obvious one. I think I mentioned that people are making games, which blows me away and I think is awesome. And it's a really fun way to, I think, do web programming. So in general, I think gaming with LiveView will be a cool way to teach Elixir to people, because it's way more enjoyable to see a game running in a stateful. You can write a stateful system and then you can kind of show that off with LiveView versus showing it to a text console. So that it does excite me, but I do think obviously if you're trying to render something on the client at the speed of key press interaction, then that's going to be a bad fit for LiveView, because ultimately there is going to be latency there, right? We can't change the laws of physics yet. So anything that requires like controlled inputs. So if you're trying to do validation at the speed of user typing, so if you're trying to format a phone number or a birthday at key press event typing, that requires JavaScript. And that controlled input case actually works with LiveView with our Phoenix hook primitive. You could write 5 lines of JavaScript to do that formatting as a user's typing, but that's not something that you would want to send to the server because of the delay. It just would be a bad experience. So one of the examples I had that was a clear example of trying to push the bounds for something that ultimately didn't work was a typing tutor application. So I wrote a typing tutor that showed like, a brown fox jumped over the log or, whatever, some basic sentences. And it just didn't work well. Like the application worked, LiveView picked up the events and showed red arrows where you typed, but it became clear that if a user expects zero latency, interaction at the speed of key press at the browser render event loop, then this is going to be a bad fit for LiveView. So I think, a typing tutor is one example that clearly was a bad fit. So I think anything that demands zero latency, whether it's games or whether it's different interaction with the keyboard, is going to ultimately require people to write JavaScript. Whether or not that rules out, let's say, all gaming, I don't think so, because a lot of like turn-based games would be perfect for LiveView. And people in Phoenix Frenzy even wrote, like someone did a flight simulator where they actually rendered SVG 3D environment, deployed it, and I was able to use it across the internet, and it actually worked quite well. So there's a gray area there, but I'd say anything that demands zero latency has to be a client-side app, or it's just going to be a bad experience. So I think that's the biggest pitfall, is just trying to do things that don't account for latency. And we are trying to, it's on the roadmap, it's not in place yet, but we want to add a latency simulator in LiveView for development exactly to address this purpose. Because our goal for LiveView isn't for people to write, mediocre experiences. We want LiveView to be like full stop, a compelling solution that can beat a single page app in some cases. And a big part of that is making sure people build, good web citizen applications that, don't expect the user to be, on a local host. So that is something that we want to build into LiveView to ensure that we allow people to not hit these pitfalls.
And so the mechanism you use for this live connection is WebSockets, correct?
Yep, it's a single WebSocket connection, and we multiplex different channels over that. So ultimately, like, you could be running multiple stateful live views and components on a page, but we would have one physical WebSocket connection.
So because of that, with these open sockets, is there any security concerns with LiveView?
None that are different than what you're used to experiencing. So internally, we generate a token. So there is this two-step process where we render pure HTML, and then the client reconnects over WebSockets back to the server, and we render the template. And the way we pass that state up is with a signed token. So, standard rules apply here, where it's the same token-based authentication that you would be used to writing for JavaScript applications. So, you want to be using SSL. And if you were to expose your secret token that you sign all your keys with, obviously all your tokens would be exposed. But this is all to say this is exactly the same implications would apply to existing token-based security that you're likely using for your React or Vue applications.
Right. And you had mentioned earlier too that you're not hydrating the same HTML over again. You're actually producing HTML, like a full page, even from the beginning. So does that mean there are absolutely no concerns for SEO, or are there still issues with SEO that may not be able to be fully addressed with LiveView?
So there are no concerns. You could yourself make it behave like a single page app, where if you're not connected yet, you could render like a loading ... page, and then when you connect, you could have LiveView render the regular page. So otherwise, by default, if you just write it like you were used to writing a template, you would just get SEO for free, full stop. Even if you hit the endpoint with curl, you're gonna get HTML. Yeah. So the only way that you would have issues is if you intentionally wanted to render the HTML content after the user connects over WebSockets. So by default, if the normal mode of operation, the normal way you would write a template, it would just work. If you hit the application with curl, you would get HTML. But if you wanted to, let's say for micro optimization reasons, render like a loading screen first, let's say behind like a logged in interface where you don't need to have an initial HTML render, you could do that. But it's not something that I have actually ever done in practice. But if you wanted to avoid, if SEO wasn't a concern and you wanted to more optimize your application, you could do so. But yeah, by default, it's just going to work, and browsers are going to get the HTML page that you render.
That makes sense. And so now that we have a full picture of the benefits, the downsides, and sort of how this works all together, someone's building an application now. They're using this for their business logic, for a dashboard. How do they go about testing LiveView components?
So we have a Phoenix LiveView test library that ships with LiveView, and it's pretty great because it allows you to test drive your LiveViews without running a headless web browser, which in my experience is never a good experience. I mean, I understand that it's a necessity. If you want to test, a JavaScript-based application and you want to fully kind of smoke test the app, you need to kind of drive it from a browser. So I get it. But that's not something we want to push by default because they're slow, they're brittle tests in my experience. So what LiveView test does is we run a LiveView Elixir client that acts just like the JavaScript client that we have, and it consumes those diffs from a WebSocket connection, just like your JavaScript app does, and you can test drive it in just pure Elixir code. So you can spin up one of these things. It's a stateful process. You can send messages to it. You can broadcast events like a new chat app. Like if you're at a chat app, you could broadcast a new message, and then you could assert that the chat live view now has that message rendered on the page. So you can test drive it in a very fast way that doesn't have all these headless WebKit caveats.
Right, and because it's actually sending the entire load, that means that in a way you could use this as a full end-to-end solution. You could actually check out the entire HTML code and say, does this match the expectation I have for what I'm seeing on the client side?
Yeah, exactly. And we don't ship with a HTML parser at the moment, so you just get a string of HTML. But what I do myself and what a lot of people do is they just bring in an HTML parser dependency, and that gives them CSS selector based tests within their LiveView tests. So it's not like you don't have to assert against an entire HTML document. You can actually do selector based tests, within this ID I expect this content to exist.
Okay, so then in that sense, this is definitely acting like a integration testing framework, or does this include elements of unit testing, integration testing, and end-to-end testing?
It includes elements of all of them. In general, I'm a fan of integration tests for your web-facing code. So we do have a live isolated, it's literally called live isolated test helper, which allows you to unit test a live view. So basically test a live view that isn't necessarily it won't go through the whole router stack. But for me, just like I recommend for regular controller tests, I recommend integration tests, just because that's the flow that the user is going to take. So the fact that I can test HTML that a controller or a live view renders, to me, isn't all that useful, because I might as well just go through the whole stack, because that's the same step the user is going to take, and it's the same assertions. So it's actually a stronger test for me to do integration tests, and because it's Elixir, it's fast, so it's just going to be fast. So you might as well do it.
And one of the things that actually reminds me of is, in wrapping this up, if you want to provide a business case for why LiveView might be a better choice than, say, React or even just plain old JavaScript, can you give some insights, for example, in doing a dashboard application, profiling between the before and the after? Do you have a sense of what kind of performance gains we've seen with LiveView?
So I don't have hard numbers yet. I will say probably an order of magnitude. If I had to guess, I truly believe an order of magnitude lines of code reduction, just based strictly on lines of code. And like I said, that doesn't account for also the server-side code that you may not have to write or that you could then get rid of. So I think speed of development, productivity is going to be unbeatable compared to a single-page app. And also data on the wire and actual latency we can beat single-page apps with. Because what I like to highlight is, if you imagine world-class single-page application, unless they roll their own WebSocket API, which most don't, every JSON interaction has to authenticate the request. It has to go through, fetch the current user, maybe do token authentication for just every interaction, right? Every post, every user is typing message, and that's expensive. That's overhead that you have to do for all requests for a user. But for LiveView, we authenticate once, and now every interaction the user takes is over an existing WebSocket connection. So no HTTP overhead, no parsing the session, no authentication. We don't have to fetch the current user from the database because we already have them. So I actually think from a development speed standpoint and a user experience standpoint, it's counterintuitive, but I think we can actually have a faster, less latent user experience with a server-rendered app compared to a single-page app, which I think is very counterintuitive. And we also produce less data on the wire. So imagine if you wrote the most naive HTML application that you could write, and then that data payload was smaller than the best handwritten JSON you could write by hand. And that's what you get for free with LiveView. So instead of coming up with serialization formats, just the natural data optimizations that fall out of the programming model is like a keyless payload that's going to beat the best handwritten JSON you could write. So I think that there are clear business wins here from whether it's a development speed point of view or even a user experience point of view.
And so to wrap up, if someone's now convinced they want to use LiveView and they want to get started, you've got your Programming Phoenix book that's out. You've also got the keynote that you did on LiveView on ElixirConf 2019. Are there any other resources you would recommend to our listeners for getting started with LiveView?
So those are great places to start. The Phoenix book just very lightly touches on LiveView because LiveView is still early. It's pre 1.0, so we weren't quite ready for the Phoenix book, but we do talk about it in the last chapter, and we show examples and we talk about the programming model. But it won't go like end to end as like a here's the full way to use LiveView. LiveView itself, if you check out the hex docs, we actually have really, really fantastic documentation in LiveView. Like the module docs are huge, and they show you primitives, and they talk about some best practices on using components. Like we have stateful components and we have stateless components, and we talk about both and when you would use one or the other. So I think the documentation actually is probably much more robust than people think. But that's where I would start, and then eventually we want to go with like full-blown guides like the Phoenix guides. But it's definitely still early in the process, so I encourage folks to get involved and definitely let us know where we need to fill the gaps in.
Great. Thank you so much, Chris, today for coming on to talk with us on Software Engineering Radio. We will link in the show notes to Chris's Twitter, as well as all these other links to the other episodes, including his keynote talks for ElixirConf and all the documentation for Phoenix Framework and LiveView. Chris, thanks again.
Thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.